Let's dive in and get started. Here's your first question. What are Python's key features? Python is an interpreted, high-level language, meaning you can run code directly without compilation and focus on problem-solving instead of low-level details. It's dynamically typed. Types are checked at runtime, giving flexibility but requiring careful testing. Python supports multiple paradigms, object-oriented for structured programs, and functional features like lambdas and map filter for concise logic. What's the difference between list, tuple, and set? Take a moment and think about your answer. A list in Python is ordered and mutable, which means you can change it any time, and it allows duplicates. Check example. A tuple is also ordered, but it's immutable, so once created, it cannot be changed. A set is unordered and mutable, but it only stores unique elements. What are Python's mutable and immutable types? Mutable types, like lists, sets, and dictionaries, can be changed after creation. You can add, remove, or modify elements anytime. Immutable types, such as strings, tuples, and numbers, cannot be altered once created. Any change produces a new object in memory, which is important for performance and memory behavior. Next, what is the difference between is and equals? The is operator checks whether two variables point to the exact same object in memory. In contrast, equals checks if their values are equal. This distinction becomes crucial when comparing lists, dictionaries, or strings. Next, what's the difference between shallow copy and deep copy? A shallow copy creates a new top-level object, but the elements inside it, like nested lists or objects, are still references to the same original objects. A deep copy, however, recursively duplicates all objects, creating a fully independent copy. This is safer when working with complex nested structures. Next, how does Python manage memory? Python uses automatic memory management through reference counting and garbage collection. Reference counting tracks how many references exist to an object. When it drops to 0, the memory can be freed. The garbage collector handles cycles of objects that are no longer reachable. Next, what is Python's GIL, or Global Interpreter Lock? The GIL is a mutex that allows only one thread to execute Python bytecode at a time. While it simplifies memory management for CPython, it limits true parallelism in CPU-bound tasks. However, it does not affect I/O-bound concurrency. Next, what's the difference between modules and packages? A module is a single Python file containing functions, classes, or variables. A package is a directory containing multiple modules and a special init.py file. Packages let you organize code hierarchically for better structure and maintainability. Next, what's the difference between instance methods, class methods, and static methods? Instance methods belong to an object and access it via self. Class methods belong to the class and take CLS as a parameter, allowing modification of class-level state. Static methods neither take self nor CLS and behave like regular functions within the class. We completed our first milestone. The basics are done. Let's move to the second part, functions and object-oriented programming. Here's your first question. What are args and kwargs? Args allows a function to accept a variable number of positional arguments, collected into a tuple. Kwargs allows a function to accept variable keyword arguments, stored as a dictionary. This makes your functions more flexible and reusable. Next question. What are Python decorators? Decorators are functions that modify the behavior of other functions or classes without changing their code directly. They use the @ symbol, placed just above the function definition. For example, a decorator can be used to log function calls, check permissions, or measure execution time. Since this concept is tricky and asked in almost every Python interview, take a look at the screen. Here's a simple decorator for adding two numbers. Notice how it wraps the function and extends its behavior. Moving on, what is inheritance in Python? Inheritance allows one class to reuse code from another. Python supports single inheritance, multiple inheritance, multi-level inheritance, and even hybrid inheritance. This makes code powerful, but can sometimes introduce complexity. Next, what is MRO, or Method Resolution Order? MRO defines the order in which Python looks for methods when multiple inheritance is involved. It uses the C3 linearization algorithm, and you can check it with the _MRO attribute. Next question. What are Python's special methods? They are also called dunder methods, short for _. Examples include init, which initializes objects, str, which defines how an object is represented as a string, and len, which returns the length. These methods let your classes behave like built-in types. Next, what's the difference between new and init? New is the method that actually creates the object in memory. Init then initializes its attributes. Usually, you only override init, but new is important when working with immutable objects like tuples or strings. Next question, can Python functions be nested? Yes, functions can be defined inside other functions. Inner functions can access variables from the outer function, which is the basis of closures, a powerful feature for encapsulation and decorators. What is monkey patching? Monkey patching means changing a class or function at runtime. For example, you could replace a library's method with your own version while the program is running. It can be useful in testing or quick fixes, but risky if misused. Next question, what is method overriding in Python? That's when a child class redefines a method from its parent class to provide a new implementation. This is how polymorphism is achieved in Python. And the last one of this section, does Python support method overloading? Not in the traditional sense like Java or C++. Instead, you can simulate it using default parameters, or flexible args and kwargs. This way, one function can handle different kinds of input. We completed our second milestone. Now let's move into the third section. Here's the question. Why is searching in a dictionary faster than in a list? In a list, Python searches one item at a time, which takes O of n time. But in a dictionary, Python uses a hash table. It computes a hash of the key and jumps straight to the memory slot, in average O of 1 time. That's why dictionary lookups are super fast compared to lists. Next question, can you use a list or a dictionary as a key in another dictionary? The answer is no. If you try, Python throws an error because keys must be immutable and hashable. Lists and dictionaries can change, so their hash would change too. Tuples, on the other hand, are immutable, so they can safely be used as keys. Next, how do you count word frequencies in just one line? Instead of writing loops, Python gives you collections counter. Just import counter, pass in the words, and instantly you get frequencies in one line. Next question, what's the difference between deque and a list? A list is great for random access, but inserting or popping from the front is slow, O of n. That's where deque comes in. It's a double-ended queue optimized for O of 1 appends and pops from both ends. Perfect for queues, sliding windows, and BFS. Next, how do you remove duplicates from a list while keeping order? Using set removes duplicates but messes up the order. The trick is to use dict dot from keys. Just wrap it in list, and you get duplicates removed while preserving the original order. Next question, why can't sets contain other sets, but can contain frozen sets? A set can't contain another set because sets are mutable and unhashable, but Python has frozen set, an immutable version. Since it can't change, it's hashable and can be safely stored inside a set or used as a dictionary key. Moving on, what's the difference between list.sort and sorted, and how do you sort case insensitively? List.sort changes the list in place and returns none. Sorted returns a new list, leaving the original untouched. If you want to sort ignoring case, use a key like str.lower, and you'll get a human-friendly order. Next question, how do you merge two dictionaries in Python 3.9 and above versus older versions? In Python 3.9 and above, you can merge dictionaries with a pipe operator. Before 3.9, people used unpacking with 2 asterisks. Both approaches are handy to know. Next, what happens if you use append versus extend? Watch carefully. If you start with a list and call append on another list, Python adds the whole list as one item, but extend adds the elements one by one. That's why the result looks different. And the final question of this section, how do Python sets check if an element exists? Sets use hashing. When you check if x is in set, Python computes the hash of x and jumps straight to the memory bucket in O of 1 time. That's why membership checks in a set are much faster than in a list, which requires O of n scanning. We wrapped up our third milestone, and now it's time to step into the fourth section. Tricky output-based questions. Here's the question. What's the output? Pause and think. The correct answer is option A. When the dictionary is created, the key takes the value of A at that time, which is 1. Changing A later doesn't affect it. So the key stays the same as in the initial definition. What do you think the output will be? Pause for a moment and comment below your answer. Most people expect 1, 2, 3. But that's not correct. Here's why. In Python, default arguments are created only once when the function is defined. Since we used a mutable list as the default, every call reuses the same list, and it keeps growing with each append. But wait, if we use a string instead, each call starts fresh. That's because strings are immutable, so Python can't reuse and mutate the same one. It has to create a new string every time. What will this print? Pause and drop your guess in comments. The trick is, brackets with comprehension are not a tuple, it's a generator. Generators can only be used once. So, the first list consumes it and gives 0, 1, 2. The second list finds it empty and prints empty list. Final output is C. What will this print? Pause and drop your guess in comments. Here's the trick. The try block wants to return 1, but Python says, hold on, I must run finally first. The finally block returns 2, which overrides the earlier return, so the final output is 2. What will this print? Pause and drop your guess. The trick is, true is 1 and false is 0. So true plus true is 2, true times 5 is 5, and false times -3 is 0. Altogether, it prints 250 without spaces, since we used the end keyword in print. Interesting, isn't it? Check out this code. What do you think it prints? Pause and comment your guess. A lot of people expect 10 and 20, but actually, it throws an unbound local error. Why? Because x equals 20 inside inner makes Python treat x as a local variable. So when we try print x, it hasn't been defined yet. To fix it, we can use non-local. This tells Python to use a variable from the outer function instead of making a new one. Remember, non-local only works in nested functions. What will this print? Take a moment and drop your guess in the comments. The key is that the star expression lets B collect all the middle values from the list. So A takes the first value, which is 1, C takes the last value, which is 3, and B becomes a list containing 2. That's why the output is 1 list containing 2, 3. What will this print? Take a moment and drop your guess in the comments. The key idea is that converting the list to a tuple creates an immutable snapshot used as the dictionary key, but the dictionary's value is still a reference to the original mutable list. So when we append 3, the key stays the tuple of 1 and 2, while the value becomes the list 1, 2, 3. What will this print? Take a moment and drop your answer in the comments. The key is that the x inside the list comprehension is a temporary loop variable that doesn't leak into the outer scope. So the outer x remains unchanged as 5. What will this print? Take a moment and drop your guess in the comments. The key is that Python first builds the tuple 1, 2 once, and then unpacks it twice, first setting A equals 1 and B equals 2, then unpacking again as BA equals 1, 2, which overwrites the earlier values. That's why the final output is 2, 1. What will this print? Take a moment and drop your guess in the comments. The key is that Python evaluates AND before OR. So first, 0 and 1 gives 1 because in an AND expression, Python returns the last value if all are truthy. And both 0 and 1 are non-empty lists, so 1 is returned. Then it evaluates empty list ORed with list 1. Since an empty list is falsy, Python picks 1. That's why the final output is 1. We've completed our 4th milestone, and now it's time to dive into one of the most exciting parts, Python internals and advanced concepts. Here's the first question. What actually happens inside Python when you run a .py file? First, the source code is parsed into an abstract syntax tree. Then it's compiled into Python bytecode and stored as .pyc files inside the _pycache folder. Finally, the Python virtual machine executes the bytecode instruction by instruction. Next question. Why can't Python threads run truly in parallel even on multi-core CPUs? The reason is the Global Interpreter Lock, or GIL, in CPython. It allows only one thread to execute Python bytecode at a time. Threads can overlap during I/O, but not during CPU-bound work, and multiprocessing bypasses this by using separate interpreters. Moving on. How does Python's memory allocation actually work behind the scenes? Python uses reference counting for immediate cleanup and a cyclic garbage collector for reference cycles. Under the hood, every object has a PyObject structure, storing reference count and type info, and small integers and short strings are interned for efficiency. Next, what's the difference between the id function and the memory address in Python? The id function returns a unique identifier that in CPython usually, but not always, matches the memory address, while in implementations like PyPy, it may not correspond to a real address. Next question, how does Python implement for loops internally? For loops don't use indexing. They rely on the iterator protocol, calling iter on the object to get an iterator, then repeatedly calling next until stop iteration is raised. Next, how does Python store and look up variables internally? Local variables are stored in a fast locals array for speed, while globals and built-ins are stored in dictionaries, fglobals and fbuilt-ins. Python resolves names using the LEGB rule, local, enclosing, global, and built-in. You can even inspect a frame's locals with frame.flocals. Next question, why are Python function defaults evaluated only once? Because default values are stored in the function object's _defaults at definition time, not on each call. This causes the famous mutable default argument gotcha. And before we wrap up, here's a bonus question. How does Python handle tail recursion? It doesn't. Python doesn't optimize tail calls like some functional languages, so deep recursion can still hit recursion limits. And that wraps up all sections. If you found this helpful, make sure to subscribe to the channel and stay tuned for more Python and system design interview prep content.